Oh, another concept. Okay, we got a bunch going on here. Consider infinite integration. Not indefinite, but infinite. Ooh, and convergence and divergence. Explain how you calculate the area under each curve from 1 to infinity. Okay, so from 1 to infinity. Well, wouldn't I set up some integrals? So integrate from 1 to infinity. That seems uncomfortable. 1 over x dx. Integrate from 1 to infinity. 1 over x squared dx. And then integrate from 1 to infinity. 1 over the square root of x dx. Alright, now, it makes me uncomfortable to have the infinity on the integral. So what if I do this? What if I rewrite this as the limit as, it's the top, so I'm going to do b. As b goes to infinity, 1 to b, 1 over x dx. Okay, so that's going to make me a little more comfortable, because that's going to be the limit as b goes to infinity of the natural log of x from 1 to b, which is the limit as b goes to infinity of natural log of b minus the natural log of 1. And the natural log of 1 is 0, because that's saying e to what power is 1. Well, as b goes to infinity, the natural log of b is going to blow up. I mean, slowly, but it's going to blow up. All right. So we did that one. Let's talk about the purple one. The purple one. Let's do the same process. Limit as b goes to infinity. 1 to b, 1 over x squared dx. That's x to the negative 2, so the underderivative of that, or whose derivative is that, is going to be b to the negative 1. Oh, I need a negative there. That's going to be from 1 to b, which is the limit as b goes to infinity of negative, I put a b there, that should be an x, I'm sorry. Got ahead of myself. Negative 1 over b minus negative 1. Well, as b goes to infinity, 1 over b goes to 0. So that's going to be 1. All right, let's check that last one. Limit b goes to infinity, 1 to b. I'm going to write that as x to the negative 1/2 dx. The limit as b goes to infinity, that's going to be x to the 1/2. Oh, I got to put a 2 there from 1 to b, which is the limit as b goes to infinity, which is 2 square root b minus 2. Square root of b as b goes to infinity also gets huge. Infinity. Okay. There's that convergence divergence thing that's mentioned up there. Well, convergence, that makes me think of like bringing things together, and then divergence makes me think of that book, but it makes me think of splitting things apart. So here's my thinking. That converges while the other two diverge. This can become a bigger deal kind of as we get deeper into calculus, but that gets us started. Okay, an improper integral. Let's see. So an improper integral seems like it's one that has an infinity somewhere. So it could be one where we have like 1 to infinity of some function. It could be like negative infinity to 1. I'm picking 1, but it could be any number. I'm just picking 1 to make me feel comfortable. I suppose it could be negative infinity to infinity. You could also have like vertical asymptotes. So you could say, 1 to 2 of 1 over x minus 2 or something like that, where we're going to have to approach things kind of from the left in that case. We might have a divergence piece going on, whereas if we put like a squared thing, we might have a convergence. I don't know. Depends on how things are going. And then how to rewrite. So basically you want to write it as limits, so use limits. Now the convention for like here would be the limit as b goes to infinity. This would be the limit as a goes to negative infinity. This you'd have to do as like a double limit, which would be a little cray-cray. This one you'd have to do the limit as you approach 2 from like the left. So it's combining some pieces that we've done so far. The convergence divergence is like, do we get a number or do we not get a number? So if we get a number, then we converge. If we don't get a number, so if we get like infinity or something, or don't get a limit at all, then the improper integral will diverge. Ooh, I love this. I'm not going to tell you this. I want you to think about this. What p-values will we converge? What p-values will we diverge? Same idea here, but notice the different limits. Create an argument for what the integral will do. Okay. I'm going to think, this is like a natural log-y thing, right? So I'm going to say that's diverges. Because we showed that this diverges. And that's going to behave similarly. That's going to be my comparison. I'm going to compare that to 1 over x. If you look at the graphs, it might help you. Can I do something similar for that one? Well, that looks kind of like this one. And so I'm going to guess that those will behave in a similar manner. So since this one converged, I'm going to guess that that one will converge. And we can talk more about it. You get to play with it a little bit. So the comparison idea is if you have one that is different, but similar to one that we've already done, in particular if you have kind of a plus and a minus and stuff like that, then you can make some conclusions. All right, now last one here. Try this integral. It says careful. So if you just like did the FTC, you'd get an answer. But that goes 0 to 2. This has a vertical asymptote at 1. So you would have to, I'm going to write that better because I just messed that up. You would have to go 0 to 1, well, 0 to b, limit as b goes to 1 from the left of this thing. And then you'd also have to do from a to 2 in the limit as a goes to 1 from the right. 1 over x minus 1 to the 4/3. And you'd have to evaluate both of those. So let me see if I can do that. So that's going to be x minus 1, so that's the negative 4/3 to the negative 1/3. We're going to have a limit as b goes to 1 from the left, from 0 to b. So that's going to be the limit as b goes to 1 from the left of b minus 1 to the negative 1/3. Minus, that's going to be negative 1 to the negative 1/3, so minus negative 1. And we have that problem. Now, as I approach as I approach 1 from the left, if I think of the graph of that b minus 1 to the 1/3, it's going to be a kind of a rational function idea. So you're going to have an asymptote. It's going to look something like this. So that piece is going to go to negative infinity. So overall, my argument is going to be this integral is going to diverge. Because I have one piece that will diverge, so my overall claim is that the whole thing will diverge.